Hello, coming for the next video, and this consists of all the problems because we have already finished with all the theory parts very clearly. Now all that we need to do or whatever is left out is only the solution of problems. So today I'm going to take up the problems related to the planes, and that directly I'll be picking from the book in this video, and then some other problems which will be extra, right? So without much delay, let me start with. I'll pick up question number 4, which is about the foot of the perpendicular drop from origin to a given plane, right? That we have to do. So I'll not write the questions very clearly because already it is marked in the book, and I'm telling you the question number, right? I'm going to do for question number, it is A. So the given plane is, I'll write the figure. The given plane is, what is the given plane? Twice x plus 3y plus 4z minus 12 equal to 0. So this is a given plane, and we have to find the image in this the foot of the perpendicular in this plane drawn from the origin. So let's go for a figure. Let us draw a figure and then see what type of figure it will be. This is the plane whose equation is already marked as 1, and then this is the origin. From the origin you have drawn a perpendicular. This is the point where the perpendicular falls. This is the point alpha, beta, gamma. This alpha, beta, gamma they are asking you to find. Now in the very beginning you should remember one very important point. Already I had been discussing. Moment you see a plane like this, 2, 3, 4 are going to represent a very special quantity. That is the direction ratio of the line perpendicular to the plane. So suppose this is the perpendicular. So what is the direction ratio? One set of direction ratio is this. And moment you see the figure, it is very clear that this line is parallel to that because both are perpendicular to the plane. So they will definitely share their direction ratios. Or in fact you can say that direction ratio of this line is proportional to this line. So that's our working principle, right? So now let's move and let's start with the answer. So we write, let n alpha, beta, gamma be the foot of the perpendicular from O to the plane, right? So very immediately you can find, therefore their direction ratios. The I should not write one set actually, but still the if I write it will not be a major mistake anyway. So you can write therefore one set of, better you write one set of gears of ON is, one set is x2 minus x1. You can remember that. So it is alpha minus 0, beta minus 0, and gamma minus 0. It will not be written in the like first bracket, it will be written in the angular bracket. That is, these direction ratios are alpha, beta, gamma. Make a difference of the point and the direction ratios. Direction ratios are to be written in the angular bracket, not in the first bracket, right? So clearly as ON is perpendicular to the plane, right? So drs of ON are proportional to 2, 3, 4. They are proportional to 2, 3, 4. And what is the meaning of proportionality? Their corresponding ratios remain same. Therefore, what I can write is alpha by 2, beta by 3, gamma by 4. Say we have used a constant of this proportion or variation. It is the constant C, right? We have used that constant of variation as lambda. Now you compare each of the ratio alpha by 2 equal to lambda. So that will give you alpha equal to 2 lambda. Similarly the other values, right? Similarly the other values. So you can write therefore alpha equal to 2 lambda, beta equal to 3 lambda and gamma equal to 4 lambda, right? You got this? Now you see, but n lies on, where does this point lie? Lies on plane 1. So if it is lying on the plane 1, therefore it must satisfy, right? It must satisfies equation 1. So if it is satisfying equation 1, what will be 1 implying? 2 times x matlab 2 lambda, right? Sorry, directly I am writing the value. I should not write directly. You first show once. 2x, x matlab alpha, because this point will satisfy. 3 beta, then 4 gamma is equal to this, right? So now you put the value of alpha, beta, gamma and then work out. Alpha is 2 times of lambda, beta is 3 times of lambda, this is 4 times of lambda and 12, I take that side. So you can count here, it is 29 lambda. So lambda will be equal to 12 by 29. So once you get the lambda, put the value of lambda here, then you will be getting the alpha, beta, gamma, and that's the coordinate of the foot, right? So we'll be doing it. Therefore record foot is, directly you can write 2 lambda. So if you multiply, it is 24 by 29. Then next is 3 lambda. So this is 36 by 29. Last is 4 lambda, that is 48 by 29. So this is the foot. This is the foot of the perpendicular from the origin to the given plane. So now see this question, and then the rest of the 3 questions of this particular question number 4 you can do yourself. It's not a difficult one, but you can very well do it, right? But important question, remember it. I'll go to the next question. I'm trying to avoid the direct questions as far as possible, but if it is little tricky but direct, that I am taking, like question number 6a I am going to take, right? Question number 6a, even if it is direct, they have given you 3 points. You have to find the equation of the plane passing through these 3 points. So you have a direct formula, so we'll be using it. But what's tricky about that? Let's see by solving it. So points are 1, 1, minus 1. First you write the given points are, we'll be naming it 1, 1, minus 1, B 6, 4, minus 5, 6, 4, minus 5, and C, it is minus 4, minus 2, 3, minus 4, minus 2, 3, minus 4, minus 2, 3. So you can consider this as x1, y1, z1, x2, y2, z2, x3, y3, z3, and then do the equation. So directly you can write clearly the equation of plane is, what will be the equation of plane? There is a determinant, if you remember, that is equal to 0, x minus x1. So this is x1, y1, z1. So x minus x1, y minus y1, and z minus z1. That means z minus minus 1. So it will be plus. Fine, that's okay. Now it is x2 minus x1. Next row. x2 minus x1, 5. y2 minus y1, 3. This minus this, minus 4. Okay. Then this minus this, x3 minus x1, minus 5. This minus this, minus 3. 3 minus minus 1, 4. Now here you observe one thing. Always be very alert while doing the problems. Here I need not expand this determinant, because one thing you observe, the second row and the third row, just they are proportional, right? Their element values are same, only the sign is different. So if you find a ratio, it is -1, right? That means see, R2 and R3 are proportional, and if it is like this, then properties of determinant says that this determinant will be having a value 0. So left side becomes 0 once you simplify, right side also comes out to be 0. Now that's the great difficult time how to face. We were expecting an equation, that's what I told you, this is tricky. So you are not getting any equation, rather you got an equation 0 equal to 0, and there is nothing wrong about this, right? So when you arrive at these kind of situations, it says that this whole equations, the whole identity or whatsoever, this equation, or I can say identity also, is being satisfied by all values of x, because there is no x left out here. All values of x, all values of y, all values of z. It means the points are collinear. They are not dependent on the x, y, z, right? So be always very clear about this. Once you get, you must write points A, B, C are collinear, right? So if these are like this, how many planes you can draw through 3 collinear points? We already discussed infinite, right? So there are infinite number of planes through them, right? So if you are getting infinite number of planes through them, it's very clear you will not be able to decide any one of them. So let the answer be finished here only for this question. Okay, so we'll be moving on to the next question. This is a tricky question. So coming on to the next question, which is again a very important question of the exercise, that is question number 9. This is about the family of planes, right, passing through the line of intersection of two given planes. So first note down the planes. Question number 9 I am taking, पहले ले लेते हैं, then we will be talking about the problem. The given planes are the first 3x minus y plus 2z minus 4 equal to 0. This is named as 1, and the other plane is x plus y plus z minus 2 is equal to 0. So hopefully both are in the same pattern, right? Ax plus by plus cz equal to d form नहीं is in the left side, no problem. For finding this, you bring in the same format, either everything to the left or maybe constant to the right. Now what exactly they are asking, I am discussing that, then we will proceed for solving the question. So suppose this is one of the plane and the other plane is here, and these two planes are intersecting each other at a line, right? Two planes, if they intersect, they will intersect always at a line. Now through that line you can draw infinite number of planes. I have to find only that particular plane which is passing through the point 2 to 1. That means if I just want to see that which plane I need to find, suppose this be the plane, and what particular peculiarity this particular plane bears, it bears that it passes through the point 2 to 1, apart from the fact that it is passing through the line of intersection of the given planes, right? So these are the equations 1 and 2, suppose, right? So they are passing through the point, this particular plane is passing through the point 2 to 1, right? So now just recall, how do you find the equation of plane passing through the intersection of two planes, right? It is in the Cartesian form, so we'll be using that. So if I write easily, you can recall it. So directly I am writing, let the equation of plane passing through the line of intersection, right, line of intersection of plane 1 and 2B, right, what it will be, this whole thing you keep fixed in the first plane, and the second you should multiply by lambda, right, lambda times this. If you want, you can keep the variable in the left side and the constant in the right side, but I did not do that particular change. But remember, after writing this, you have to bring this in the simplified form, that is ax plus by plus cz equal to d form, because then we will be applying the conditions. So you bring it. So this is for x, for it is 3, and here it is lambda is coming. Then for y it is minus, and then here it is lambda, and then here it is 2, and here it is plus lambda z, and the constant I want to take to the right side, so 4 will go that side, and then this is plus 2 lambda. Mark the equation as star. Now all that I need to find what is the ultimate equation star is, right? So for that I need to know the value of this lambda, right? Now here only I have to use the condition that the plane is passing to the point 2, 2, 1, right? That is the additional condition which helps us to find what is lambda, right? Always in these problems you will be getting one additional condition to find the value of lambda. So now as this plane is passing to the point A, what is the observation? It will satisfy that particular plane equation, right? This is a normal concept, right? So you can write, since star passes through point A 2, 2, 1, therefore it must satisfy equation star. It must satisfy equation star. So once it will satisfy, definitely I can replace the value of x, y and z by these particular coordinates, right? So we'll be doing this and see what will be the value of lambda. Therefore star implies, put the values, it is 3 plus lambda 2, then minus 1 plus lambda, this is again 2, then 2 plus lambda, it is 1, right side it is 4 plus 2 lambda. So now all that you need to find is the value of lambda. So do it in the same step, right? Because now plus 12 students you can do it. So first find what is the lambda. It is 2 lambda, 2 lambda, and then 1 lambda, 5 lambda. Bring that 2 lambda this side. 5 lambda minus 2 lambda, 3 lambda. So that lambda coefficient will come down here, right? Once you simplify, fine. Then constant 6, then minus 2, 4, 4 plus 2, 6. Take that side. So 4 minus 6 will give you minus 2, right? So your value of lambda you can obtain directly. That's it. So once you obtain the lambda, all that you need to put here, and once you put it here, you're done. You just simplify and find what is the ultimate simplified equation. So we are going to do that, right? Now all that I need to do is to replace the value of lambda in equation star. So let us do it. Therefore star implies, what will star imply? 3 minus 2 by 3x. I am directly replacing it here, adjusting the sign. You can do it. So here it will be minus 1 minus 2 by 3 y. Then this is 2 minus 2 by 3 z, and right side it is 4 minus 4 by 3, right? 2 times 2 by 3. Now if you try to observe, all the fractions are having the same denominator. So the denominator will be cancelled from both the sides, right? So you can simplify it in the same step by here, what? Just avoiding the denominator, right? In the first step itself. but you do not forget to multiply this, right? Otherwise your answer will be wrong. So 9 minus 2 will give you 7, then minus 3 minus 2 minus 5y, then 6 minus 2 4z, and then 12 minus this 8. So this is where you finish with, and this is the required equation of the plane, right? So we have finished with this. Now one more problem of this kind I'm going to take. Let's start with this problem, right? That is I'll take up one question of vector form also, but not now, right? Next problem, right? That is question number 11. I'll take question number 11. Here you have to draw, sorry, you have to find the equation of plane passing through intersection of two planes which is perpendicular to the third plane, right? So what are the two given planes, right? Given planes are you write the given planes, that is x plus y plus z equal to 1. This is number 1, and the other one is twice x plus 3y plus 4z equal to 5. That is number 2, right? So these two are going to intersect in a line. Through that we can draw infinite number of planes. Out of that I have to find that equation of the plane which is perpendicular to the third plane given here as x minus y plus z equal to 0. That also I'll write. And the third plane is x minus y plus z equal to 0. This is number 3. So let us first see this through a figure. What we'll understand by the question. So suppose these are two planes. It is one and another is this. This is plane 1 and this is plane 2. Right? Now they are intersecting here in this line. Through this line, how many planes you can draw? Many, infinite. So suppose this is the plane which I am in need. I need this plane. What is the criteria of this plane? Last problem I told you that there is a separate criteria. The criteria is that it is perpendicular to another plane. Say there is a plane and this is number 3. My required plane is perpendicular to this. Now I'll be using the condition of perpendicularity for proving this or for finding this. So let's start, right? So first we can consider the equation like as usual, right? Let the equation of the plane B, required plane B, see this I'll consider as 3 x plus y plus z, and this I'll consider as the multiplier of this lambda, that is twice x plus 3y plus 4z, and right hand side will be 1 plus 5 lambda. So before you mark the equation, make sure that you write this as in a standard form. So that will be 1 plus 2 lambda times x, then 1 plus 3 lambda times y, then 1 plus 4 lambda times z, and this is 1 plus 5 lambda. It is star. Just remember, last time we had a point which was satisfying this equation. This time we do not have a point. Rather we have a plane to which it is perpendicular. So now you have to remember immediately what is the condition in which two planes are perpendicular, right? It's what? Component wise product of the direction cosines and their sum should be 0. That is a1 a2 plus b1 b2 plus c1 c2 0. What are a1 a2 a3? These are these coefficients of this plane, and it is perpendicular to this, means we have to consider here 1 minus 1 and 1, right? So this is what the conditions I have to apply. So you can write now, given star is, right, perpendicular to plane number 3. Therefore, condition says A1, A2. This is A1 and coefficient here nothing is mentioned, means 1 is A2. This is B1 and B2 is here. This is C1 and C2 is here, and this also be giving you 0. A1 A2 plus B1 B2 plus C1 C2 is equal to 0. Now you work on to find the value of lambda, and ultimately you have to put it here. So what you will give, directly we will find, make it a habit of finding it like this. So denominator will be the coefficient of lambda. What you will get, 2 lambda plus minus 3 lambda. So minus lambda plus 4 lambda, minus lambda plus 4 lambda, 3 lambda. So 3 will be coming here. Then the constant 1 minus 1 cancelled. Then this is 1. So this side it is 1. If you transfer to the right side, it will be minus 1. So minus 1 by 3 is the value. Now you have to replace it here. Just do it. Therefore, star implies 1 minus, directly we will be writing 2 by 3x 1. Do not cancel this 3 here, right? It is 3 times 1 by 3. Why I am telling you? Actually, as I told you, I will be writing the answer in the same step. So by chance if I cut it, I might forget that I need to multiply this by 3, right? So because of that, now choice is yours. You can do your calculation yourself. This is here, and this is minus will be there, minus of 5 by 3, right? So now all that I need to work on, and I have finished with the calculation, the last result. Okay, so you do in the same step. 3 minus 2, 1x, right? Then it is 3 minus 3, 3 minus 3, 0. That means there will be no presence of y. Then 3 minus 4, minus z. And then this is 3 minus 2, minus 5, minus 2. So your answer is this. If somebody wants to write like this, they can write it. So this is the answer. So this is the required equation of the plane. It's a very easy part. Only thing is that you have to remember, you have to be able to easily comprehend what exactly they are asking you, right? So I will not be picking up problems which are direct, like perpendicular distance of a point from a plane, right? Angle between two planes. These are very direct questions. So these questions I do not want to take, that you do yourself, right? I'll close this now. I'm going to take some other problem. Okay, I take a problem where students commit mistake, right? So that problem I'll be taking. That is, if lines are perpendicular, find the value of k. It is from the miscellaneous exercise, question number 6. It is of line, not of plane. Question number 6, miscellaneous exercise. Your given lines are x minus 1 by minus 3, then y minus 2 by minus 2k, plus 2k, then z minus 3 divided by 2. This is number 1, and the other is this line. These are perpendicular. These are perpendicular. So if these are perpendicular, then you have to find the value of k. So two lines perpendicular means their product, the product of the components of direction ratios and when added algebraically should give you 0. So a1 b1 c1 a2 b2 c2. But see here, before that you have to take care of two things very clearly that I already discussed. Again I am trying to discuss because line equations I did many questions. This should be always in the form of x minus a, something like that. If anything other than this will be there, you have to adjust it. So here directly I am applying conditions will be what? A1 into A2 plus B1 into B2 plus C1 into C2, that should be 0. This is the condition. How should we write? Since 1 and 2 are perpendicular, this is the conditions. So now just find the value. Here also make it a habit of finding the k directly. First you find the coefficient of k, bring it down here. It is minus 9k and it is plus 2k. Minus 9 plus 2, minus 7, 10. Take that side, minus 10 will become plus 10. So your value is this. So very directly within say 2 minutes you can find this. Fine. Next problem we'll visit. Problem of lines and planes will be now taking. Okay, mixed problem. Question number 13. Question number 13 of miscellaneous exercise. I am reading the question so that you can easily recall that. You have to find the equation of a plane passing through the point minus 1, 3, 2 and perpendicular to each of the plane. There are two planes, right? Not equation of line, they are asking plane equations. Little different. This is not family of planes, right? Okay. So the given planes are, first we write given planes are. What are the given planes? What are the given planes? See, this question if you do in vector, it will be easier. But as it is given in the Cartesian, I will not do it in the vector, I will do it in the Cartesian only. This is one plane and the other plane is 3x plus 3y plus z equal to 0. And there is a point through which the plane passes. It is minus 1, 3, 2. So that also will write, and point is E minus 1, 3, 2. What exactly you have to do? Just think. This is the plane whose equation I need. This is the plane whose equation I need. Fine. What type of criteria it is satisfying? First you observe that, then you make sure you try to relate them. First thing, it is passing through the point A. Suppose this be the point A, it is passing through the point A. So can you find any plane which is passing through a point? Is there any standard form? Yes, it is the second form, right? So right at this moment only, I can consider the equation of the plane as, I should have written A. If you remember, I already have given you one shortcut. Ax plus by plus cz is equal to ax1 plus by1 plus cz1, where x1, y1, z1 is this point. So likewise also this we can do. Anyway, that is not an issue. I'll be doing that only. But what are ABC? Is the direction cosines or direction ratios of the line perpendicular to it. We call it capital A in the deduction, but here we will not say because already point A is used, otherwise you will be getting confused. So this equation will be considered as ax plus by plus cz, and then ax1 means this point, it is minus a, then plus 3b and then plus 2c. This is the equation of the plane I consider. Let the plane be this. Okay, then we'll be applying the condition. Let the plane be, if I write the draw the figure, then I have got a lot of support, right? So directly if I write, there is no problem. Let the plane be this, right? It is minus a, it is 3b, and then 2c. This is the plane. Now what is the two criteria it satisfies? It is perpendicular to two different planes, 1 and 2. That means suppose there is another plane here like this, to which it is perpendicular, and there is another plane here to which it is perpendicular. So if these two are perpendicular, criteria to relate them is what? A1 A2 plus B1 B2 plus C1 C2 equal to 0. So this way you have to do. Let's proceed for doing that. Since star is perpendicular to plane 1, so we'll be getting that component wise multiplication and then addition 0. So it is A with 1. That means I'll be getting A, then B with 2, then B with 2, 2B, and then C with 3, 3C equal to 0. This is set 1 dash. And star is perpendicular to 2. Then we get 3A, then 3 times B, 1 times C is equal to 0. Now once you solve this two, your task is done. Now let's solve them by method of cross multiplication. So cross multiplication, all of you know that already you came across at class 10. So we'll be applying the method of cross multiplication for solving 1 dash and 2 dash. Therefore, by method of cross multiplication, right, multiplication, we have here the variable as A, B and C. Okay, in our class 10 we had a constant here, not C, but here we are getting, so we'll be getting the solution as proportional numbers. Okay, that's fine, we'll be able to manage that. So for writing A, what I should multiply? I have to remove these coefficients. You remember that I'm doing a rough work here. You have to write the coefficients here like this, right? These coefficients 3, 3, 1, and then again one line here for cross multiplication. Then for x, A, I have to avoid this, so it will be 2 minus 9. 2 minus 9 will give you minus 7, right? Then for B, I have to take this. This is 3 minus 9 minus 1. It is going to give you 8. And for first one, it is 3 minus 6. 3 minus 6 is minus 3. So these all will be equal to, say, lambda. You may not use lambda here. Directly also you can use these values. There is no problem. So what will be? A equals minus 7 lambda, B equal to 8 lambda, C equal to, it means ABC are those direction ratios which are proportional to whom? Minus 7, 8, minus 3. So now you put it in this equation, right? Then it's done. So you will be getting the equations. Of course, again I am telling you that this is easy in factor form. Therefore, star implies, star was the equation, I think, if I am not wrong. So here you put the value of ABC. 7 lambda x, then 8 lambda y, minus 3 lambda z is equal to minus of A, that is 7 lambda, then it is 3b, so 24 lambda, and then 2c, that is minus 6 lambda. So throughout lambda will get cut, there is no problem at all. So it is minus 7x, 8y, minus 3z, and then here it is 25, right? 25. So now you can do one thing, this 7 can be made plus, this is a leading coefficient. So this is the last equation, right? So today I finish here with this particular problems. One more video I'll be doing where I'll be taking some advanced problem, advanced in the sense some horse questions, right? So till then, bye and all the best for the next videos.